Fuel pumps dispense fuel, a highly flammable liquid. Vacuum cleaners, especially those with brush motors, present a potential ignition source. The electric motor inside a vacuum cleaner can create sparks during operation. These sparks, even small ones, are sufficient to ignite flammable vapors that may be present around a fuel pump. Gasoline vapors are heavier than air and tend to accumulate near the ground. A vacuum cleaner operating in close proximity to a fuel pump can draw these vapors into its motor housing, increasing the risk of ignition. The risk of fire or explosion is significantly increased when a vacuum cleaner is placed near a fuel pump. For safety reasons, vacuum cleaners should not be installed or operated near commercial fuel pumps. The presence of flammable vapors creates an inherently hazardous environment, and any potential ignition source must be avoided. Placing a vacuum cleaner near a fuel pump introduces an unacceptable risk. The electrical equipment used in hazardous locations, such as those around fuel pumps, must be specifically designed and rated for use in such environments. These devices are built to prevent sparks or other ignition sources from coming into contact with flammable vapors. Standard vacuum cleaners are not designed for use in hazardous locations and should not be used in such areas. Regulations and safety codes typically prohibit the use of non-explosion-proof electrical equipment near fuel dispensing systems. These regulations are in place to protect people and property from the dangers of fire and explosion. Regular inspections and maintenance are essential to ensure that fuel dispensing areas remain safe. This includes verifying that no unauthorized electrical equipment is present and that all safety systems are functioning correctly. Employees working in fuel dispensing areas should be properly trained on the hazards of flammable liquids and the importance of following safety procedures. This training should include information on the proper use of equipment and the procedures to follow in the event of a fuel spill or other emergency. Signs and warnings should be posted in fuel dispensing areas to remind people of the hazards of flammable liquids and the importance of following safety regulations. These signs should be clearly visible and easy to understand. The area around a fuel pump should be kept clean and free of debris that could contribute to a fire hazard. This includes removing any spilled fuel or other flammable materials. It is important to follow all applicable safety regulations and guidelines when working with flammable liquids. Failure to do so can result in serious injury or death. In conclusion, vacuum cleaners should never be used near fuel pumps due to the risk of fire and explosion. The presence of flammable vapors creates a hazardous environment, and any potential ignition source must be avoided. Safety should always be the top priority when working with flammable liquids. Proper training, maintenance, and adherence to safety regulations are essential to preventing accidents. Remember that even a small spark can ignite flammable vapors, leading to a catastrophic event. Always be aware of the potential hazards and take the necessary precautions to protect yourself and others. The specific electrical codes pertaining to hazardous locations are outlined in the National Electrical Code (NEC). These codes provide detailed requirements for electrical equipment and wiring in areas where flammable liquids or gases may be present. It is imperative to consult the NEC and other applicable standards when designing or installing electrical systems in fuel dispensing areas. The NEC classifies hazardous locations based on the type and concentration of flammable substances present. These classifications determine the type of electrical equipment that is permitted in each area. Explosion-proof equipment is designed to contain any internal explosion without causing ignition of the surrounding atmosphere. Intrinsically safe equipment is designed to operate at low energy levels that are insufficient to ignite flammable vapors. The use of explosion-proof or intrinsically safe equipment is often required in hazardous locations. Regular inspections and testing of electrical equipment are necessary to ensure that it continues to meet the requirements for hazardous locations. Any equipment that is damaged or malfunctioning should be repaired or replaced immediately. In addition to the NEC, other organizations such as the National Fire Protection Association (NFPA) also publish standards and guidelines related to fire safety in fuel dispensing areas. These standards provide valuable information on topics such as ventilation, fire suppression systems, and emergency procedures. Compliance with these standards is essential to ensuring the safety of fuel dispensing facilities. It's crucial to understand the properties of the fuels being dispensed. Different fuels have different flash points, which is the lowest temperature at which a liquid produces sufficient vapor to form an ignitable mixture with air. Fuels with lower flash points are more easily ignited. Gasoline has a very low flash point, making it particularly hazardous. Diesel fuel has a higher flash point, but it can still pose a fire risk under certain conditions. Proper ventilation is essential in fuel dispensing areas to prevent the accumulation of flammable vapors. Ventilation systems should be designed to effectively remove vapors from the area and exhaust them to a safe location. The design of a fuel dispensing facility should take into account the prevailing wind direction. This can help to prevent the accumulation of vapors in areas where they could pose a hazard. Fire suppression systems, such as fire extinguishers and automatic sprinkler systems, should be readily available in fuel dispensing areas. These systems can help to control a fire in its early stages and prevent it from spreading. Employees should be trained on the proper use of fire suppression equipment. Emergency procedures should be in place to address fuel spills, fires, and other emergencies. These procedures should include instructions on how to evacuate the area, notify emergency services, and contain the spill or fire. Regular drills should be conducted to ensure that employees are familiar with the emergency procedures. Consider the implications of static electricity. Static electricity can build up on vehicles, clothing, and other objects. A static discharge can ignite flammable vapors. Grounding straps should be used to dissipate static electricity from vehicles before fueling. Customers should be instructed to avoid using electronic devices while fueling, as these devices can generate static electricity. Maintain all equipment, including fuel pumps, hoses, and nozzles, in good working order. Leaking fuel or damaged equipment can increase the risk of fire. Regular inspections and maintenance are essential to identify and correct any problems. Ensure that all fuel dispensing equipment is properly labeled with warnings and instructions. These labels should be clearly visible and easy to understand. Consider the use of vapor recovery systems. Vapor recovery systems are designed to capture and recycle fuel vapors that would otherwise be released into the atmosphere. These systems can help to reduce air pollution and improve safety. Be vigilant about preventing spills. Fuel spills can create a significant fire hazard. Care should be taken to avoid overfilling fuel tanks and to prevent spills during fueling. Spill containment equipment, such as absorbent pads and booms, should be readily available. Regularly review and update safety procedures. Safety procedures should be reviewed and updated on a regular basis to ensure that they are effective and that they reflect any changes in technology or regulations. Encourage employees to report any safety concerns. Employees should be encouraged to report any safety concerns they have, no matter how small they may seem. A proactive approach to safety is essential to preventing accidents. Remember that fire safety is everyone's responsibility. By following these guidelines, you can help to create a safer environment for yourself, your coworkers, and your customers. Always err on the side of caution when dealing with flammable liquids. If you are unsure about a particular situation, consult with a qualified safety professional. The principles of electrical safety are paramount when dealing with any electrical equipment, especially in potentially hazardous environments. Understand that electricity always seeks the path of least resistance back to its source. This is the fundamental principle behind electrical circuits and also the basis for many electrical hazards. Grounding is a crucial safety measure that provides a low resistance path for electricity to flow back to the source in the event of a fault. This helps to prevent electrical shock and also allows circuit breakers to trip, cutting off the power supply. Double insulated tools and equipment are designed with 2 layers of insulation to protect against electrical shock. These tools do not require grounding. Ground fault circuit interrupters (GFCIs) are devices that detect even small amounts of leakage current and quickly interrupt the power supply. GFCIs are commonly used in areas where there is a risk of electric shock, such as bathrooms and kitchens. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. Arc flash can produce extremely high temperatures and can cause severe burns. Personal protective equipment (PPE) such as arc-rated clothing and face shields should be worn when working on or near energized electrical equipment. Lockout-tagout procedures are used to ensure that electrical equipment is de-energized and cannot be accidentally turned on while it is being worked on. These procedures involve placing locks and tags on the equipment to prevent it from being energized. Never work on energized electrical equipment unless you are properly trained and qualified. Even experienced electricians should avoid working on live circuits whenever possible. Use insulated tools when working on or near electrical equipment. Insulated tools are designed to protect against electrical shock. Regularly inspect electrical cords and equipment for damage. Damaged cords or equipment can pose a serious electrical hazard. Avoid overloading electrical circuits. Overloading a circuit can cause the wires to overheat and can lead to a fire. Be aware of the location of overhead power lines. Contact with overhead power lines can be fatal. Maintain a safe distance from overhead power lines when working or operating equipment. Underground utilities can also pose an electrical hazard. Call before you dig to locate any underground utilities before starting any excavation work. Use caution when working in wet or damp environments. Water can conduct electricity and can increase the risk of electric shock. Avoid using electrical appliances near water. Never touch a downed power line. Downed power lines can be extremely dangerous. Call the power company immediately to report any downed power lines. The principles of electromagnetism are also relevant to understanding the operation of electrical equipment. Electromagnetism is the interaction between electricity and magnetism. Electric motors use electromagnetism to convert electrical energy into mechanical energy. Transformers use electromagnetism to transfer electrical energy from one circuit to another. Inductors store energy in a magnetic field. Capacitors store energy in an electric field. Resistors limit the flow of current in an electrical circuit. Diodes allow current to flow in only one direction. Transistors are used to amplify or switch electronic signals. Integrated circuits contain millions or even billions of transistors on a single chip. Digital electronics uses binary code to represent information. Analog electronics uses continuous signals to represent information. The principles of electronics are used in a wide variety of applications, including computers, cell phones, and medical devices. Always follow safe electrical practices to prevent accidents and injuries. Continuous learning and education are essential to staying up to date on the latest electrical safety standards and practices. Remember, respect electricity and always take the necessary precautions to protect yourself and others. Fuel pumps incorporate a variety of safety features to minimize the risk of fire or explosion. These features include shear valves, which shut off the flow of fuel in the event of a collision, and emergency shut-off switches, which allow operators to quickly stop the flow of fuel in an emergency. Fuel pumps are also designed to prevent leaks and spills. Regular inspections and maintenance are essential to ensure that these safety features are functioning correctly. The specific requirements for fuel pump safety vary depending on the location and the type of fuel being dispensed. However, all fuel dispensing facilities must comply with applicable safety regulations and standards.